All righty. Well, hello, everyone. Oh, wow. Man, post-lunch crowd. Oh, man. It's going to be rough. Okay, but I have something for you, so don't worry about that. So, yes, like he said, my name is Ben Ilegbodu. I'm here to talk about Fiber and talk about React 16 and what's going on there. But instead of focusing on the implementation, on the architecture of Fiber, I want to instead focus on what it means for us developers. Like, how is it going to impact how we develop, how we build our React applications? So before I get started, though, I wanted to mention that I tweeted out a link to the slides. So if you go to my Twitter handle, BenMVP, you can find a link to the slides. So in case anything is too small to read or you just want to have that alongside to follow along, you have that as well. So just wanted to give that out. So now, since it's post-lunch and you know that food is going to start digesting in our bodies and you're going to have that glazed look over your face, I want to get everyone to stand up. So can I get everyone to stand up? We're going to stand up, okay? So if you can see me, what we're going to do is we're going to do 10 squats like this, okay? And we'll do it all in unison together. So I'll count it out, right? So if you're unable to do the squats, please do not feel self-conscious. You don't have to do the squats. You can just do the arm things. Like, you can do whatever works for you, okay? But we're going to do all 10. And since this is a React conference and we develop in JavaScript and most of us are developers, we're going to start at 0. So it's going to be a 0-based counting, okay? So, all right. You guys are ready. Here we go. We're going to do it together. Ready? 0. Yeah. 1. 2, good job. 3, bend those knees. 4, 5, 6, all the way, it's burning. 7, 8, 9, oh, and that's it, yeah, 9. You almost had a buffer overrun. Good job, good job. Have a seat, have a seat. Oh, almost had an off by 1 error there, but we're good. Okay, so now that, to introduce myself again, like I said, I'm Ben Ilegbodu. I'm a Christian, a husband, and a father. This is my wife, Rashida. We'll be married 7 years in 10 days. 10 days, I believe, so yes. Awesome, excited about that. And we have 2 girls, Simone and Avery, and it's very hard to take pictures with them, so I just took a whole bunch and it got this animation out of it. So Simone is 3.5 years old, and Avery will be a year old in a week. So next week, Thursday, she'll be a year old. So excited about that as well. So we live in the Bay Area in a small town outside of San Francisco, about an hour outside of San Francisco, called Pittsburgh. So Pittsburgh without the H, Pittsburgh, California, not Pittsburgh, Pennsylvania. And I am an engineering manager at a company called Eventbrite. So I'm assuming you've heard of Eventbrite before, but just in case you haven't, we're an online ticketing, events and ticketing platform. So unfortunately, this conference did not use Eventbrite. They used one of our competitors, but that's okay. There's no hard feelings. It's all good, but you know, next year you can talk to me. Maybe we can work something out, okay? So I'm a manager on our destination team, and this team is kind of chartered with trying to make Eventbrite a destination for where you would go to find events to do. So typically you go to Eventbrite because you went to some conference website or you went to some music artist website and they told you, hey, go buy your tickets on Eventbrite. You bought them and that's all your interaction with Eventbrite. But we want you to come and discover and browse and find things to do at Eventbrite. So that's kind of what we're focusing on right now. But we've been spending the last year and a half or so of trying to transition all of Eventbrite.com from a Backbone marionette stack over to React. So we've had a lot of experience with that. And I'm sure a lot of people have had the same experience too, going from Backbone over to React. So I'm also a huge basketball fan. I love playing basketball, I love watching basketball. And I'm originally from Houston, so I'm a huge Houston Rockets fan, hence this t-shirt. And as a result of being a huge Houston Rockets fan, I'm also a huge Utah Jazz hater, okay? Like, I completely hate the Utah Jazz. I know, this is not the place to say that, but I have to share it. And it all started with this shot 20 years ago, 2 months, and 25 days ago. This shot happened. John Stockton in his super short shorts hit this shot and knocked us out of the Western Conference Finals, and we couldn't play the the Bulls in the finals just because of this. I know there are not that many basketball fans here and probably people who are old enough to even remember this happening, but it was not amazing, okay? It was the opposite of amazing, okay? And I'm still bitter to this day, okay? But, okay, now that I've gotten that off my chest, we can talk about React Fiber. Okay, so React Fiber. A little bit about the background of it. So it's a complete rewrite of the reconciler. And we heard Lynn talk about it a little bit earlier today. The reconciler is the part of React that determines, that allows us basically to write our code such that we can write it as if the whole UI is going to be rewritten. We just write it as a function of the state. So it figures out what the state was of the UI before, what the state is after some changes happened, and it does all the optimizations so that it tells the renderer the precise changes to make to the DOM, so that's super performant. And so the reconciler then, now the Fiber reconciler now will allow us to prioritize UI updates so that things that are of higher priority can happen before things that are lower priority, so you can have better performance in your UI. And the result of that is asynchronous rendering. So you may have a component that starts rendering and then the rendering goes, time is released back to the main thread, and then something else will render in its place and then come back to render. And I'll talk about that in a little bit. So React Fiber is now being released in the next major version of React, which will be version 16. So the current React reconciler that's in React 15 was kind of posthumously named the Stack Reconciler. So it didn't have a name before, but they gave it the name the Stack Reconciler. And as you can see here in this diagram, if you're rendering something big, a huge portion of the component tree, it'll render all the way until it finishes the whole component tree. So if you have something really big or something really expensive to render, a lot of time is going to be spent in that render call, and nothing else in the browser can happen because the main thread is spending its time doing all of this reconciliation. So now we have the Fiber reconciler, which will periodically relinquish control back to the main thread so that you can have a more performant UI. So if something is really expensive to render, it may pause, go back to the main thread will do something and then come back and continue rendering with that. So, and it gives opportunities for higher priority things to render in place of it. So those priorities look like this. So the synchronous priorities are kind of how it works currently. It just renders all the way through. You can have tasks, which means that this should render at the next tick. Animations mean it needs to happen at the next frame. High priorities means this thing needs to render pretty soon, like you're typing on a keyboard. Low priorities are things that are coming from maybe an API request, so there's already the delay of making that request, so it doesn't have to be immediate. Then you have your off-screen priorities, which are things that we want to display coming up soon. So that's kind of a brief overview of the architecture. That's really all the time I want to spend on it right now, because Lynn actually did a great job talking about it at ReactConf back in March. Like, it was just amazing how great that talk was. It actually inspired me to give this talk here based upon what she did. And every time I was looking at resources for Fiber, every time I looked somewhere, they would describe something, and this is kind of how this thing works, but if you want to know how it really works, just watch Lynn's video, basically. And every time I saw that all over, and her video actually has 75,000 views on YouTube, which is amazing. And the React repo itself only has 74,000 stars, so Lynn is better than React. Just amazing job. But so now instead of talking about the architecture, I actually want to talk about how our code is going to be different, how we're going to write different code. So first thing I want to talk about are the React packages here and how they're handled, okay? So the first thing about the React packages are that they are 20% smaller than what they were before. So React 15 had a certain size. Now with React 16, it's 20% smaller. So the React library is significantly smaller. You can see from 7 kilobytes to 2 kilobytes, or 3 kilobytes rather. And then the React DOM library also shrunk a little bit. So without even having to write any code, without having to do anything, just by importing the new versions of React, you have that reduction in the bundle. And then next, the deprecations that came with React 15.5, where you got those warnings because you were using prop types off of React, or you're using React.create class. All those deprecations that you've been ignoring and saying you're going to put off until later, well, later is now coming. Okay, so those will now be errors in React 16. So those methods, those properties, those are no longer on the React object. So you now need to import prop types, that library. You also need to import the create React class library for using create class still in order to do those. And there are code mods to be able to do those as well, so you can easily change your code so that you don't have to manually do it yourself, but it's a warning to know that those deprecations become errors. And I imagine that part of the reason why the React library got smaller is because they pulled those things out into separate libraries. Okay, moving on. So let's talk about new return values that we have for components, which should make some folks excited. So if you had a component, let's say you had a page component right here, and it has an H1 called heading, and it has a page body component. And in that page body component, what we want to do is return an aside in that section, and we want those to actually be siblings of the H1. Like, that's what we want to do. And if you first start off with React, this is probably something you've tried to do, because in other templating languages, those that are string-based, this is something that you could totally do and just stick it right in there. We want to factor page body out into a helper class so that we can kind of separate concerns, but we still want it to go right there as a sibling of H1. And this was really necessary for things like Flexbox or Grid, where you have to have them as siblings. But if you actually try to run the code, it won't compile, and it'll give you that error that you need to have an enclosing tag around the aside, around the section. So then in the end, what we do is we end up adding divs, we end up adding spans all over the place, just for the purposes of enclosing tags together. So we end up getting a whole lot of tag bloat in our React applications. I was taking a look at the Eventbrite design system, a kind of a React component library that we've built, and there's so many just empty divs that aren't doing anything but just wrapping a whole bunch of content just for this purpose. So I'm getting to it, then you can woo, okay? Just hold that for a slide or two. Adjacent JSX elements are still an error in React 16, actually, because it turns out it's invalid JavaScript. It actually has nothing to do with React itself. But we have a workaround now because we can return arrays with our React components now. So yeah, now you can clap. All right. And the thing is, like, in reality, I know you're not actually clapping for me, you're clapping for the React team, but I'm gonna accept them, okay? So keep the claps coming, keep them coming. So now we have this static markup, right? This fixed markup that we wanna return. We can wrap it in an array and return the markup as an array, and then now they will become siblings of the H1. But the syntax is kind of funky because you have to have that array, right? So now you're mixing the array with JSX. And when I always mix JSX with JavaScript, I tend to wrap it into parentheses to kind of signal to my brain, to other people, that I'm transitioning from JavaScript to JSX. So that already makes it kind of clunky. And then whenever you're returning an array, as we know, we have to also include a key as well, so that React can do the reconciliation of arrays. So even though this is fixed static markup, we still have to add the keys because React will complain if we don't put it there. So now I just have dummy keys, key aside, key section, just to satisfy the unique constraint. So that's also kind of annoying to have to do that for all of the top level components inside the array. So earlier this week, I actually stumbled upon a kind of cool idea. The concept is called a self-eradicating component, basically. So we have this aux component, and it takes in the props, and all it does is just return the children. And now, since the children can be, we know that children can be an element or it can be an array, and now since components can return arrays, this will be a valid component. And we wrap the aux component around the aside in the section. And since all it does is just return the children, when we put it, when it actually renders out, the aside and the section will end up becoming siblings of the H1. So really all it does is just kind of take what it gives it, takes what it gets and then returns it back. And then now it allows you to put it as siblings without having to have that array wrapper and the keys and things like that. So it's a pretty interesting idea. This library here, React Aux, all it does is export the component that does just this. So that's like literally all the library is. The idea being that if you saw that in some code, you would wonder, hey, what's this library? Go read the documentation, and then it explains exactly what's going on. So it's an interesting idea. It would help with the div bloat or the tag bloat and not have to use the arrays. So those are arrays. Also, strings are valid return values as well. You probably haven't run into this issue too much. The only real use case I could think of is like a internationalization type component where you want it to take in a string, take in some tokens, do the translation for you, do the interpolation for you, and then return it back to you. So it's kind of basically like a function that's in the tag form so that you can kind of have the declarative syntax, but now you can actually return strings, you can return booleans, you can return numbers if you need to as well. So all the scalar values are valid return values too. Okay, let's keep going. Let's talk about handling errors. So now in React 16, if an error happens in your app, your entire app will get unmounted. That means your entire page is going to go blank by default. That's what's going to happen. So before, if you had an error in your app, you would still see the UI, but it'll be kind of broken. You couldn't do anything, and it's just in this weird state that you can't really recover from. So now the React team decided, they went back and forth with it, but decided that they were just going to unmount the entire app. Because imagine it's a checkout app that you're building or something really sensitive, having it being in a broken state could be really problematic. So I'm using create React app here, so it gives me that nice little overlay when an error happens, but if I hid that error overlay, then it would be blank right behind it. But luckily though, if you can read the screen, kind of maybe not see the screenshot, it gives you kind of a hint. It says, hey, maybe you should use this thing called an error boundary. And it gives you a link to a description of our blog post about error boundaries. So I'm going to kind of describe what those are. What an error boundary is, or error boundary component is that they introduced this concept of a new lifecycle method called component did catch. So we have component did mount and component will mount and all those other things, component did update, but now we have component did catch. And that will give us an error, the error that it happened, and then information about the error, so the stack trace and things like that. And we can now use that to build an error boundary component that can message to the user when an error happens and catch that error. So we'll have some state. That state will have a has error property that will initialize to false. So then when the UI renders, no error happens, all it will do is just return this.props.children, and everything happens kind of like normal. But then if an error happens, component did catch will get triggered. So an error that happens with lower down in the component hierarchy, if an error happens there, it'll bubble up to this component did catch. Then we'll set state to true. And then as a result, the error boundary component will re-render. And then now this dot state that has error is true. So then it will render out this message. And here I have an H1 that says something went wrong. So you can make that be as elaborate as you want. Kind of have instructions to reload the page or do something different. You can do whatever you want in that render of the error boundary, but it won't render when there hasn't been an error, and then there is an error, then it will render. So you can use the error boundary like you can use any other component. You just wrap whatever component you want to in its whole tree hierarchy, and anything that happens beneath will get bubbled up to it. And so then you can use it now on sections of your site. So if you have independent sections that have different interactions and you don't want one section to impact another section if it fails, you can wrap that part in an error boundary, and then if an error happens, the rest of the page can still work, which is pretty cool. But it's important to note that if an error happens in the actual error boundary, then it won't catch itself. That'll get bubbled up higher up. And if you don't have anything higher up, then again, your whole page will get unmounted. So then what I suggest as well, I guess, is that you wrap the entire app or the top level routes in an error boundary. So that if anything happens on the route, on the page, then you'll be able to catch that error. And now we're basically kind of simulating like server-side errors, 500 errors that happened, but now doing it on the client side. So for some reason, something on the page broke, you can't render it, you can now have an error boundary that's rendered on the page, and you can say something like reload the page or go to this other page, sorry, this page is not working right now. Anything like that you can do with the error boundary. And the nice thing is that you could actually have your navs outside of that error boundary so that the user could still navigate in your header, your global header, and things like that, but the actual page below has the error boundary in the message. So that's pretty cool. And I would suggest that the second you migrate to React 16, that you add an error boundary, because your pages will go blank and you'll probably notice some cases where that starts to happen, where you're missing it before. Okay, let's talk about rendering on the server, which can have its challenges, I guess. And we don't want to have to resort to having to do this. So on the server, we use render to string to take our components and render them out to a string, which is actually super useful in React to be able to do that, to be able to just have that ability. And rendering on the server is important for user performance, initial page load, SEO, those kind of things. So prior to in React 15, the markup that was rendered had all these data React IDs filled with it. And even though we had gzip, which was somehow will compress it a little bit, it added additional markup. And now with React 16, there's no more data React IDs in our markup. It's all just blank and normal HTML. You can clap for them and me as well. Go ahead. You can clap. We'll take it. So the data React IDs in the past were used so that the client, the rendering that happened on the client and the rendering that happened on the server could be correlated so that it could know where to attach the event handlers and things like that. But now React just tries to do its best to figure out that correlation. And it will give you helpful errors if you have differences between the server and the client. But one thing to note, though, is that now if you're hydrating your client-side app from initially rendered server data, you have to use this new method on the React DOM library called react-dom.hydrate instead of react-dom.render. So if you use react-dom.render, it'll give you a warning and say that, hey, this is being deprecated, and it's actually going to be removed in the next major version of React, so React 17. So it's just a quick switch to switch from render to hydrate. And then there's performance improvements that are happening with React 16 and server-side rendering as well. So across the different versions of Node, we have Node 4, Node 6, Node 8.2, and then 8.3 as well. We can see kind of how React 16, the yellow on the right of each one, and how much it improves it. And kind of a short anecdote, at Eventbrite, we were unwittingly using the development version of React 15 in production. We didn't realize that we were doing this, and we saw that immediate jump, that 2x performance boost from just going from your development build to the production build. So I would suggest everybody make sure you're setting your process.m variable to production when you're releasing to production, because you get these huge performance gains just from setting one environment variable. But then now also moving into React 16, we'll see even a better improvement happening with that. So this is baseline testing or benchmark testing. You may not see these exact numbers, but it's pretty relative, and you should see that as well. But even with all of these performance boosts, right, rendering to a string is still suboptimal, because you have to still create this entire string on the server before you return it back to the client. So the client can't paint anything in the browser until the whole markup has been rendered. And the server also has to allocate all of this memory for this string. So if you're rendering something pretty huge, that's a whole lot of memory that you have to have on your server at any time. And you can find that your server is spending a lot of time just rendering components instead of everything else on it, and it can kind of hog the CPU use. So the preferred approach is to actually use streaming. And now streaming has first-class support inside of React. So before there was React DOM string, that was kind of the prior art to this and kind of the inspiration for it. But now on the React DOM server module, you can have render to node stream. You import that, and then you can render out that way. So now, before the whole component, the whole tree has been rendered, the browser can start rendering some of it as well. So you can get that performance. One thing to note, though, is that the server code, the server implementation was like the last things that the team was building as far as I have figured out. So they're probably the things that are going to be the most buggy with the initial release, but they've been catching a lot of bugs. People have been finding it all on our behalf so that React 16 can be really stable when it comes out. So last thing is that basically Fiber, the reconciler makes renderers, it should make renderers a whole lot easier to build because now we have this clean separation between the reconciler and the renderers. And here we have 23 different renderers on the page, on the screen. Obviously we know about React DOM, we know about React Native. We heard Devin talk about React Hardware earlier. There's React Sketch App, React VR, like all these different renderers can make use of the same reconciler that's gonna be performant and have all of these great qualities to it. So if you want to use this right now, it's pretty simple. You just install yarn add React at next, React DOM at next, or npm install it as well, and it will just replace the version of 15 that you have. And as of right now, the latest is a beta 5 build, the third kind of release. For some reason, there wasn't a 2, and 4 was immediately succeeded by 5. So provided that you've replaced all of your warnings, you fixed all those warnings, upgrading to React 16 should just work. Like the team prioritized having backwards compatibility in React 16 with this new reconciler over adding additional new features. So it should just work for you. Async scheduling, kind of like the cool new feature, the part that Lynn talked about in her talk about Fiber, is turned off in the initial release. So it won't be there. There'll be a future release that will have a feature flag so that you can opt in and turn it on, but initially it won't be there. However, if you can keep this between me and you, there is a way that you can get it now, okay? So what you have to do, the secret code to getting it, okay? You gotta open up your node modules, go into React DOM, and go into the React DOM development file. Okay, essentially what you're gonna do is go into this JSON object and turn something from false to true manually. Okay, so Fiber async scheduling false to Fiber async scheduling true inside that file. And then now that'll enable you to use this unstable property called unstable deferred updates. Okay, so it's not that hard to do, but yeah, you have to do this, okay? And what that enables you to do a low priority update. So something that came from an API request, you wrap your set state call in it, and then it'll be made a low priority. And if you go to this React Fiber resources, it actually has a live example that you can play around and see how it works. But one thing that's important though is that with this approach, that the updater function that you pass to set state instead of just passing an object, using that function syntax becomes much more important because it's obviously going to be asynchronous in this case. And what we get from this experience is we go from this kind of synchronous rendering where we're spending all this time doing this rendering to giving, relinquishing control back to the JavaScript engine to be able to do some work and then come back and continuing rendering. So we're actually seeing it really happen in the browser. What Lynn described to us so eloquently in cartoons, we're now seeing in the real browser with that experience, turning that flag on. So to conclude, there's something from Dan, just tells us that the Fiber gives us the architecture that's flexible enough so that we can do cool things, but it's going to take a while for us to see all those cool things. The first thing we're seeing is the async rendering, but there's going to be many cool things that are coming in the future, so excited to see all of those things. And then here I have some resources for you, some link to different blogs and resources if you want to dive any deeper into some of the things that I talked about. And lastly, I just want to give a couple of shout outs. Wanted to shout out the React Rally organizers, the whole team, for inviting me to be here and throwing a wonderful conference. So can we give a hand clap for Matt? Give a hand clap for Jameson for doing such a great job. We're only like a quarter of the way through and it's already going great. So looking forward to hearing all the rest of the talks. I want to thank Eventbrite as well for supporting me and allowing me to come out and share what we've done, what I have learned as well. And yes, oh, by the way, we're hiring. And if you happen to come and interview, I have to make sure that you are a quality web engineer. So of course, I'm going to ask you to sort a linked list, right? In C++, of course, on the back of a cocktail napkin in purple crayon. That's what we're going to make you do. No, just kidding. You have great interview processes, so don't worry about it. But please, if you're interested in developing UIs and building React, come talk to me about it afterwards. And lastly, thank all of you as well for coming and listening. When I go to conferences, I love that moment where I see something and I'm like, oh, I got to look into this more, or I get really excited to apply what I just learned, or I go back to work and I'm like, yo, we gotta start doing this, or yo, we gotta stop doing this. Like that's that feeling of going to the conferences, and I hope that kind of the main reason, one of the reasons I do this is so that I can give you that feeling. So I just really hope that from this talk, you're able to get something that will hopefully make you a better developer. And if you have any feedback from me, it's greatly appreciated. So that's basically it. If you want to chat with me, you can find me on Twitter. That's the best way to contact me. You can also email me if you have any questions, or I have an AMA up there that you can follow. Or better yet, if you're here in the audience, not on the stream, just come find me and grab me, and you can be awkward, you can be cool, doesn't matter. We can just chat about whatever questions you have. But if you're a jazz fan, just don't let me know, okay? Deal? All right, thank you very much, guys.